So this is symmetry. This is talking about how a particular shape behaves. So the first one we have to talk about is line symmetry. Line symmetry should mean that one half of the shape on one half of the line looks the exact same as the shape on the other half of the line. Another way that I commonly show that is that if it has line symmetry, you should be able to fold the paper and fold the shape over that line in a way that makes it overlap perfectly. So you should be able to fold it over that line so that it is perfect. So this one on the left does not have line symmetry because it would not fold nicely that way, but the one on the right would have line symmetry. If I folded it over that line, it would overlap perfectly. That shape to the left of the line and the shape to the right of the line look the exact same. Then we have rotational symmetry. The idea behind rotational symmetry is that we look at how far we need to rotate so that the shape looks exactly like it originally did. So if I rotate this once, click, there it is, looking the exact same as how it started. And here it comes again, click, and click, and click, and we're back to where we started. That rotational symmetry is happening every 90 degrees that we rotate it. And one way you can determine that is that we went all the way around 360 degrees, and how many times did it click? How many times did it lock in exactly how it looked at the start? Well, 4. There were 4 times in that 360, so 360 divided by 4, that's 90 degrees. So every 90 degrees, there was rotational symmetry. That's the idea there. So let's look at a couple of examples here to give us the idea. All right, we basically did the square. So let's go over to this shape over here on the right, which, if you remember your shapes, this is called a hexagon. Hexagon because it has 6 sides. So let's take a look. We have, we're going to start by drawing our line symmetries. Our line symmetries. So we've got one here. If we fold it over that line, it's going to look the exact same. We've got one right here. That's 2. And then there's more. Here's 3. Here's 4. Draw that a bit better. Here is 5. And here is 6. If I fold over any of those lines that I just drew, then it will overlap perfectly with what it originally looked like. So we have 6 lines of symmetry. And then for rotational, we're going to look at how far we need to go before it looks like it originally did. So let's keep track of this here. We're going to turn it. No, we're not turning that. We're turning the shape. Here it is. So click 1, click 2, click 3, click 4, click 5, click 6. So that is taking us in a journey all the way around 360 degrees. And how many times did it click? 6. So we divide it by 6, and that gives us 60. So every 60 degrees, there was rotational symmetry. By the way, that 6 times that it clicked was the same as the number of lines of symmetry, not an accident. It in fact does typically work out that way, but the lines of symmetry and how much rotational symmetry matters. One more thing I want to point out is it needs to look exactly the same as it did. So you know, it's not in these notes, but some stuff like color and pattern and something like that, it would matter. It needs to look exactly the same. I should not be able to tell the difference between the original shape and the new shape if I'm working with it. All right, let's do one more. Let's do the triangle down here in the bottom left. So we have, we're going to look at the line symmetry first. And we see a single line of symmetry, which is if I draw a line straight up and down. Yes, vertical. That's my line of symmetry. So there is one line of symmetry. And then if we look at our rotational symmetry, let's see how far we're going. So it needs to look the exact same here. So we're going to see if we click into place. Well, that's upside down. That's certainly not it. Oh, we went all the way around. So that doesn't count because we're just back where we started. So this, in fact, has no rotational symmetry. Because instead, except for winding up back where we started, there was no place that we rotated it that gave us the symmetry we were looking for. So that's line symmetry, folding it over that line. Rotational symmetry, spinning it around so that it clicks into place and looks exactly like it started.